Hi, and welcome to this Now Maths revision video on calculating compound interest with a calculator. Firstly, we need to know what interest on savings is. Well, it's a percentage of an amount that's in a savings account that's paid to its owner either yearly, monthly, or even daily. There are two types of interest we need to be aware of, both simple and compound. In this video, we'll focus on compound interest. Compound interest is where the amount of interest changes as the amount in the account does. So, for example, if no money is withdrawn from the account and the interest rate stays the same, the amount of interest earned will increase as the amount in the account increases. Now let's get into our first example. So in this question, Ed invests £1,200 in a savings account that pays 4% annual compound interest. This means that Ed will gain 4% of the amount in his account each year. The question then goes on to say that Ed will not add any money or make any withdrawals from the account, and we need to work out how much money will be in his account after 3 years. The first thing we're going to do to help us answer this question is come up with a decimal that will increase by 4%. So to work out a decimal that will increase by 4%, we're going to start with 100% and add 4% on, which gives us 104%. We're then going to turn 104% into a decimal by dividing it by 100. So 1.04 is the decimal multiplier that increases by 4%, because if we multiply any number by 1.04, that number will increase by 4%. If you need more help with this step, please check out the video linked now. Now this question tells us that Ed starts with £1,200 in his savings account. So we need to work out how much he will have after 1 year in his account. And after 1 year, the amount will have increased by 4%. So we're going to do £1,200 multiplied by 1.04, which tells us that he will have £1,248 in his account after 1 year, because this is the amount he started with, increased by 4%. Now the question asks us how much will be in his account after 3 years. So now we need to work out how much he'll have after 2 years and then how much he'll have after 3 years. So after 2 years, he'll have the amount that he had at the end of the first year increased by another 4%. So we're going to do £1,248 multiplied by 1.04. which tells us that he'll have £1,297.92 after 2 years. Now for the third year, he'll have the amount that he had at the end of the second year increased again by 4%. So this time we're going to multiply £1,297.92 by 1.04 again. So at the end of the third year, if we type this into a calculator, he'll have £1,349.8368. Of course, if we're working with money, we're going to round this to 2 decimal places, so he'll actually have £1,349.84 to the nearest penny. The method we've just used has obtained the correct answer to this question. However, if the question asked how much he had in his account after 5 years or 10 years, or perhaps even more than that, this method could get quite lengthy. So we're now going to take a look at how this method could be made slightly shorter. So we're going to keep the fact that 1.04 is the decimal multiplier that increases by 4%, because this will still be helpful. And for our alternate method, if Ed starts with £1,200, what we did first was we increased this by 4% by multiplying it by 1.04. We worked out the answer to this, and then we multiplied that by 1.04 again. We then worked out the answer to that, and we multiplied it by 1.04 again. And we could have in fact typed that in our calculator all in one go, as you can see on the screen now. Of course, the same issue arises as before, that if this was for 5 years or 10 years, you would have to start typing quite a lot more into your calculator. So instead of multiplying by 1.04 3 separate times, we could write this as multiplying by 1.04 cubed, because that does the exact same thing and it gives us a slightly shorter calculation to work with. If we then type this into our calculator, we obtain the answer of £1,349.8368. And again, if we round this to 2 decimal places because we're working with money, this gives us an answer of £1,349.84, which is exactly the same answer as we obtained previously. However, this time we've done it in one simple calculation rather than 3 separate calculations. We're going to use this method to work out the answers to the rest of the problems in this video. Now let's have a look at our second example. So in this question we have Amy who opens a bank account that pays 1.7% compound interest each year. Amy initially makes a deposit of £700, and if Amy does not add or withdraw any money, we need to work out what her investment will be worth in 5 years. Now, a 1.7% compound interest rate means that Amy will gain 1.7% of what's in her account each year. So we need to work out a decimal multiplier that will help us increase by 1.7%. If we're increasing by 1.7%, we're going to work out 100%, add 1.7%, which is 101.7%. And then to turn this into a decimal multiplier, we're going to divide by 100, which is 1.017. So this is the decimal where if we multiply by it, we increase by 1.7%. So Amy initially makes her deposit of £700. So to increase £700 by 1.7%, we're going to multiply by 1.017. Now, we need to know how much Amy's investment will be worth in 5 years. So we need to multiply by 1.017 5 times. Or we could multiply by 1.017 to the power of 5. This makes it one nice simple calculation for us to type into our calculator, and when we do so, we get this long decimal of £736 and so on. And then because we're working with money, we round this to 2 decimal places to give us an answer of £736.31. Let's take a look at our third and final example for this video. So in this question, Theo opens a savings account that pays 3.25% compound interest annually. Theo deposits £8,620 into the account, and the question tells us that he will not make any changes to the amount in the account. We need to work out the value of Theo's investment in 7 years. So the 3.25% compound interest rate tells us that Theo will gain 3.25% of whatever's in his account each year. So we need to work out a decimal multiplier that will help us increase by 3.25%. So to do this, we're going to work out 100%, add 3.25%, which is 103.25%. And then we're going to turn this percentage into a decimal by dividing by 100. So the decimal that increases by 3.25% is 1.0325 when we multiply. So in this case, Theo is depositing £8,620. So we're going to multiply £8,620 by 1.0325 to increase by 3.25%. And then because we're asked to find the value of his investment in 7 years, we're going to raise this to the power of 7, because that's the same as multiplying by 1.0325 7 times, once for each year. We then type this into a calculator and we get a decimal which has 4 decimal places in it. So we need to round this to 2 decimal places, and this tells us that Theo will have £10,782.95 in his account at the end of the 7 years. Thank you so much for watching this Now Maths video on working with compound interest. Please like this video if you found it helpful and subscribe for more help with your maths, and we'll see you next time.